Hello friends, my name is Shubham Vishwakarma and I am a BTech student from Techno India NGR Institute of Technology Udaipur. In one of my engineering projects, I have developed Intel 8085 application in C programming language. Please have a look on it. Starting with the application, it has 7 options: writing the assembly language program, viewing the opcodes, creating the data file, running the simulator, help window, quitting the simulator, and shutting down the system. Starting with the first option, it's an assembly language window. Will ask for the program counter value. Once you have entered the program counter value, you will be asked to enter your mnemonics, your assembly language program. Entering the incorrect instruction will generate an code error. Once you have completed with your program, you can save it using the keyword commit. After committing your program, the program will be saved and will be ready to run. During the writing program, if you want to edit any program counter, holded value that you have entered before, you can do so using an exit keyword. Once you have entered exit, the simulator will ask to re-enter the program counter value and will take you to the same memory location where you can change your mnemonic. Now, once you have done this, you need to save your program using commit. After committing, you can run your simulator with 4th option. Once the 4th option is encountered, it will ask for a program counter value. Please enter the valid program counter value. If the opcode is not recognized, it will throw an error. The simulator window will look like this. Below, you will be seeing the next instruction that will be executed. Simulator consists of registers and flag register. Registers shown are accumulator, BC register pair, D register pair, HL register pair, stack pointer, program counter, and memory location. The bits in the flag register are also shown: sign bit, 0 bit, auxiliary carry, carry, parity, and the flag register itself. You can also see the total number of teach states that are executed. Once the simulator has run, you can save the results using a data file option. By default, the file will be stored in the doc format. Here you need to enter the processor frequency, and in the doc format you will be getting the time for executing the total number of T states. This is how the folder of simulator will look like. Make sure where you have a simulator executable, you also have a license file, else you will not be able to run the simulator. To get the help window, you need to have 8085 simulator tutorial. The doc file will be generated at the same location where you have a simulator executable. Now let's have a look on the simulator. I am running the simulator. Now let's have a small program to add 2 numbers and store the results in the data file in a doc format. I am pressing 1. It is asking me to enter the program counter value. Enter the code. Moving the data into a register. Moving the contents of A into the memory. Now moving the contents of B to the memory, you need to increment the HL register pair. Now add the contents of B with the contents of accumulator. Increment the HL register pair and move the results into memory. Once your assembly language program is completed, now let's save using commit. Now let's have a data file for input. Option 3 is create data file. Name of the data file, processor frequency. Now you can see the data file is created at the same location. Opening it, you will see that no changes are encountered in the data file since you have not run the simulator. So all values are 0, and this is what the instruction that you will be putting into your simulator and will be running. Closing this file, going back to the simulator, now let us run the simulator with option 4. This is a simple pop-up license file requesting you to suggest any changes. Closing this will allow you to run the simulator. Entering the program counter value. Now this is what the simulator will look like. Below you can see the next instruction to be executed. It says MVI A, 15. On pressing the enter, the changes will be reflected in the simulator block. Now the next instruction is moving the data into the memory holded by the accumulator. The memory is pointed out by HL register pair, that is 0000. The current data is 0. After execution of this, the HL register pair will hold data 15. Pressing enter, similarly executing all the instructions one by one. We have data in accumulator as 3A, the result of addition of 2 instructions. Now let us create the output file after running the simulator. Option 4. Now let us see the output executable. Here you will find that data is loaded. Thank you for using.